Hi everyone, welcome once more to this YouTube channel, Best Science Brain YouTube channel. Today we're going to look at another illustration of rectangular prism refraction experiment and also aim at demonstrating Snell's law. So this is tagged model 2. We have done the model 1 part of this experiment, and as we promised, we're going to do up to 5 different types of experiment involving rectangular block prism to examine how questions can be asked using this equipment. So if you are not subscribed to the channel, kindly move down to the channel's name. As the video is playing, you find the channel's name beneath the video, Best Science Brain. Then under the channel's name, you see the subscription bell, a tiny bell, subscription written on it. Tap on it only once and get subscribed for more videos. So we'll go to the question that says, you have been provided with a rectangular glass prism, optical pins, and other necessary apparatus. Using the above diagram as a guide, carry out the following instructions. Number 1, fill the drawing paper provided on the drawing board. Number 2, place the prism on the drawing paper and trace the outline A, B, C, D of the prism. So look at the prism. See the outline A, B, C, and D. Go to number 3. Remove the prism. Mark a point O on AB such that AO is 1/4 of AB. So let's understand it. Let's look at the prism. This face is AB. So we're going to measure the length AB. If AB is giving us maybe 12 cm, we'll find 1/4 of 12, which is 3 cm. Then AO will now be 3 cm. We'll mark this point AO, which is going to be 3 cm. So everything depends on the length of your prism. So if your prism is 16 cm, you find 1/4 of 16. If AB is 16 cm, you find 1/4, which is 4 cm. So your AO now becomes 4 cm. You mark the point AO. So let's go. Number 4, draw a normal through O. Draw a normal through O. Let's go to the diagram. The normal is a straight line. That straight line drawn through O, making angle 90 with the face of the prism AB. So it's called a normal. So now go to number 5. It says, also draw incident ray to make angle I 425 degrees with the normal at O. Also draw incident ray to make angle incidence for 25 degrees with the normal at O. So you can see the incident ray making an angle. The angle of incidence is the angle between the incident ray and the normal. So 25 degrees should be made there. Then number 6, fix 2 pins, P1 and P2 on the incident ray. Replace the prism. We'll now go to the incident ray and fix 2 optical pins, P1 and P2, and then replace the prism. Then number 7, fix 2 other pins, P3 and P4, such that the pins appear to be in a straight line with the images of the pins P1 and P2 when viewed through the block along DC. So what we'll do now is we'll replace the prism here and then view through the face DC and observe the images of P1 and P2 through the face DC. We have to slant our head, close one eye, and slant your head so that you can see the images of P1 and P2 on a straight line. So when they're on a straight line, you now place the pin P3. And then after you place P3, which will block the images of P1 and P2, you also use the scum pin and place P4. When you place the pin P4, you're going to block P3, and also the image is going to block everything. You're going to block P3 and then P1 and P2. Okay. We now have join P3 and P4 and produce it to meet DC at L. Also draw a line OI. So go here, we'll join, which is a straight line, join P3 and P4, then produce it to meet the DC face at the point I. Then we'll draw a straight line from I to O. to get the lateral displacement from I to O. Okay, having done that, we now have number 9. With O at the center and using a coordinate radius, draw a circle to cut the incident ray and the refracted ray at E and H respectively. Maintain this radius throughout the experiment. You now go to use your protractor, your compass, and choose any coordinate radius, and then draw a circle with O at the center. Draw a circle with that radius around this point to cut the incident ray at E and cut the reflected ray at H. So that radius you're going to choose will be maintained all through the experiment. So if you choose 3 cm, you're going to use 3 cm all through the experiment. If you choose 4 cm, you're going to use 4 cm all through the experiment. If you choose 2 cm, you use 2 cm all through the experiment, depending on the size of your prism. If it's a small prism, you can use 2 cm. If it's a medium or big prism, you can use 3 or 4 cm radius. Number 10, draw the perpendicular EF and GH. Perpendicular means a straight line that makes angle of 90 degrees, EF and GH. So let's go back to the circle. So from the point E, that E is the point where the incident ray cut the circumference of the circle. From point E, draw a straight line to meet the normal at F. And then from the point H is where the refracted ray cut the circumference of the circle. You draw also a straight line to meet the normal at the point G. So this is your EF, this is your GH. So let's continue. 11, measure and record small letter D equal to EF, small letter L equal to GH. D, small EF, then L, GH. So let's go back. We'll measure EF and call it a small letter D. We'll measure GH and call it small letter L. Number 12, repeat the procedure for 4 other values of incidence, angle of incidence, 35 degree, 45 degree, 55 degree, and 65 degree, respectively. In each case, measure and record D and L. Okay, we're going to repeat the experiment with 35 degree, 45, 55, and 65 degree. And each case, measure D. That D is EF and L is GH, the perpendicular distances. Then plot a graph of D, that D is the EF, on the vertical axis against L, which is GH, on the horizontal axis. State 2 precautions taken to ensure accurate result. 15, state Snell's law, and 16 is the calculation that says, calculate the critical angle of water-air interface. Take reference index of water as 4/3. So as we say, this is a simple experiment that you as a student can demonstrate without even being in the laboratory. So how do you do that? You go and buy rectangular glass block. That's what you need. You buy the glass block, you buy the optical pins, you buy mathematical set, you buy thumb pins to staple the white paper on the board. You also need a softwood drawing board, or better use a PVC board. PVC is softer than drawing board, so that when you pin put the pins on the board, they will stick firmly without bending. So that is it. So we'll now start the experiment. So to start the experiment, we'll first of all trace the outline. You can see the outlines of the prism. 1, 2, 3. We did it for the first 3 set because you should be time conscious of the experiment. It's a very simple one, but you have to be time conscious. So to be fast, we have to trace 3 first, and then A, B, C, D, the outline. Then, as we are told, we are supposed to locate a point called O on AB. And that point O is 1/4 of AB. So we have to measure AB. The length AB the length AB is 10.3. 10.3. So that is our AB is 10.3 30 cm. We'll now measure we'll define 1/4. So 1/4 of 10.3 is approximately 2.6. 2.6. So we'll now measure 2.6 from the point A. We locate 2.6. And this point is our O. Also, for this other phase, we locate also 2.6. And that becomes our point O. For the other third one, we want to locate the distance 2.6 on the face AB. That is O. Then when we have done that, this is the point where we draw our normal. A straight line is drawn at this point. That straight line is called the normal. You have to make it straight. So you have that. I will still draw this one. A straight line, our normal, and then also our normal here. A straight line. So having done that, what we'll do is we're now going to get the angle, the angle of incidence, the first experiment, the angle of incidence is 25 degrees. So we have to make sure that the baseline of the protractor, the baseline covers AB, while the line of 90 degrees covers the normal. So I have to do that. The baseline of the protractor is lying on AB, while the 90-degree line is covering the normal. We'll now get 25 degrees. This is 10, 20, 25. 90 minus 70 is 20. Then the next middle line is 25. This is the incident angle. So here our I is 25 degrees. For the other one, we'll move the same procedure. The baseline of the protractor will cover our AB, while the thick line of the 90 degree will cover the normal. So this one is 35 degrees. So to get 35 degrees, you get it right. So, okay, it's all right. 35 degree, 10, 20, 30. 90 minus 60 is 30. The middle line is 35 degrees here. So I here is 35 degrees. So go to the third one, being fast on it. Be time conscious. So this is 90 here, and then the baseline being covered by the protractor. This angle here is 45 degrees. The measure 45 degrees, the incident angle. 90 minus 50 is 40. Then the middle is 45. So spot here as 45 degrees. So the incident angle here is 45 degrees for the third experiment. So having done that, we'll now join the angle, the place we marked to the prism. So this means angle 25 degrees. The same thing here. We'll now join this point to mark to the face AB. I'm very conscious. Keep your ruler straight. So we'll have to join the line to make angle 35 degrees. Okay, having done that, move to this one. Keep our protractor very well. The baseline covering line AB. 90 degrees line covering the normal. And of course, here is already 45, already done. So we'll now join the line. Move draw a line from O to meet that angle, to meet that dot. So having done that, we'll now start the experiment. We're going to fix 2 pins. The first pin on the incident ray, that's our P1, as we are told to do that in the question. Make sure the pin is on the line. So when you're done that, fix another pin, the scum pin, that is P2. Maintain a distance of at least 4 cm as a precaution between the first pin and the scum pin. So at least 4 cm. So that they should not be too close. That will give you an error. So you have that. So having done that, you make sure the pins are erect. They are on a straight line. Then we return the prism and then view the image with a search pin. So let's do that. Make sure the prism cover the outline very well. And then we'll now go to view the image from the face DC. So make sure that one pin, the first pin cover the scone one. To get the image, the first pin cover the scone one. So you slant your eye, of course your head, to get it right. So we have it there. We now put the scone pin. The scone pin will block, the second search pin will block the first search pin and block everything entirely, even the images inside the prism. So when you are done that, we can now remove these pins and then remove these other two also. So as we are told, this is P1, the place is P2. We now join these two pins, P3 and P4, with a straight line. We joined it to the face DC of the prism. So you see that. So this point is called I. Then with another straight line, you join the point I to the point O, a straight line. You join I to O. I'll be very sure that you're getting it straight. So we have that. So we have it. So go to the next experiment. For this one, we fix two pins. The first pin is P1. So we'll also maintain distance of 4 cm. And then we'll get our P2. So it's a precaution they have to maintain. The pins should not be very close to themselves. Then return back the glass block. Then you now view the pins from the face DC. So you view and watch for when the two pins in a straight line, this one will be blocking the other one. So it's here. We have it. This pin will block the first one. Okay, so have it right. So remove these pins, and then this is our P3, our P4. So we join the two with a straight line to hit the face DC at the point I. And mind you, here is our P1, here is your P2. This is for angle of incidence of 35 degrees. So we'll now join with the ruler, we'll join point O to I with a straight line, and we'll join point O to I. So you have it there. We'll go to the third experiment. You see how fast we are. So if you follow our procedure, you do it very fast. So before you know it, in less than 30 minutes, you are done with the equation. So we'll put another pin here, incident pin, on the line. Please, on the line. Let it not be out of the line. So that is it. Our P1. Then we'll now measure the distance we keep is 4 cm between one pin and the other, not less than 4 cm. We can still use 5 cm, but be consistent in the distance you're using. So we have it, the two pins on a straight line. Return the prism, and then we view the images from the face DC. So make sure the prism cover the outline very well. From the face DC, we can now view the images and how to be sure. So we now go down to view the images of the pins, whereby the first pin is covering a cone 1 and you're not seeing the second one, that's when they are in a straight line. You have to adjust your eye and adjust your head. You don't just pin the search pin anywhere you want. You have to adjust your eye and adjust your head and neck until the first pin, the image you're seeing, the first pin is block the second pin. That's when they're in a straight line. Then you put another second pin to block the first search pin. So having done that, that is right. Now remove the pins. So this place are P3, place are P4. So would now draw a straight line passing through P3 and P4. So this point is also our eye. Remove these pins, and then this is P1. This is for the angle of incidence of 45 degree now. So you join the 2 points, you join I to O. You join I to O, you have that with a straight line. So that is it. The incident ray is entering, the emergent ray is leaving. For the first angle of 25, the incident ray is entering, you show your arrow, the emergent ray is leaving. You see that? So incident ray is entering, the arrow is going in, refracted ray is leaving, emergent ray is also leaving for angle 35 degrees. So let us now make the circle we're asked to make. So to make the circle, we're going to choose a coordinate radius. So since our prism, 1/4 of it is approximately 2.6. So I choose a whole number. 2.6 is, the nearest whole number is 3. So I choose radius of 3 cm. Radius of 3 cm. So from the meter rule, so you can see it's 3 cm. So having done that, I'll take you to the first experiment where the angle of it is 25 degrees. I put my pin on O, gently on O. Then I draw a circle. I'm going to draw a circle. So let me get it clear. If I'm making a mistake, I draw a circle around the arrow here. I shifted. So let's get it clear again. 3 cm. Without mistake. Okay. Maintain a constant radius. I'm going to clean this and correct it. So we now draw the circle with 3 cm radius. So that's okay. Using a short pencil. Go to the second experiment. But we'll have to still make sure that we're having 3 cm also, that there's no shift on the radius. Okay, that is it. We'll now put our pin as center 0 and draw a circle. The protractor is shifting. So I have to clean it up and then repeat the drawing. Come back. Okay, that's right. So having done that, we'll still maintain the 3 cm. It is still correct. Come to the fourth experiment. Put your pin at the center O and then draw your circle. Don't shift it. Make sure the pin, the needle of the pin is at the center to avoid error. So we made circles here now. So the next thing to do is this. We'll draw a perpendicular, a line from the circumference where the incidence ray cut the arc or cut the circle to the normal. So draw a straight line. This point is our E. This point is our F. We also draw that straight line from the point circumference where the refracted ray cut the arc to the normal. I'm very sure what you're doing. These points are G. These points are here. This is for angle 25 degrees. The same thing, you do it here. You draw an arc from the point where the angle of the incident ray cut the circumference of the circle to the normal. Draw a straight line, a perpendicular. So here is our E, here is our F. The same thing. Go to the refracted ray, the point where the refracted ray cut the circumference. You just draw from that point to hit the normal. So this is our G and our H. So you come to this one, the same thing. From the point where the incident ray cut the circumference of the circle, you draw a straight line from that point to the normal. These are G, these are H. Then from the point where the refracted ray cut the circumference, you draw a straight line. So this is our G, these are H. So we're going to measure, these are E, there's an arrow here, E, and this is our F. While down we have G and H. E and F, G and H. These for 45 degrees. So we're going to measure this E, F, and G here for each of the angles. So for this one, our EF is 1.3 cm. So for angle 25, EF, which is equivalent to small letter D, is 1.300 centimeter. When I measure GH, our GH is 1 cm. So GH, which is equivalent to small letter L, is 1.00 centimeter. So go to angle 35. For angle 35, our EF is giving us approximately 2 cm. So EF is 2 cm and EF equivalent to D, 2.00 cm. The GH here is giving us 1.2. So GH, which is L, is 1.200 centimeter. So move to the third one for angle 45 degrees. Angle 45 degrees, our EF is about 2.5 cm. So EF is 2.500 centimeter. And EF, is equivalent to small d. Then our GH, which is L, is now equal to, we're going to measure our GH. Our GH is giving us 1.6 cm. So our GH is 1.600 centimeter. So as you watch, you see that as the angle increases, the values of D and L increases. For 25 degrees, D is 1.3, D is EF. L, which is GH, is 1.0. For 35 degrees, EF or D is 2.0, while GH or L increase slightly to 1.2. For angle of incident of 45 degrees, EF or D is 2.500 and GH is or L is 1.600 cm. So go to the remaining two experiments. So we start with this one. This is the outline already drawn for you. And this point is O, which we'll be using as 2.6, which is 1/4 of the face AB, 2.6. So we're going to draw the normal, the straight line. Draw a straight line, that normal. Passing through the point O, that is the 2.6 mark. Then we'll now measure out angle 55 degree, angle instead of 55 degree. Make sure that the baseline of the protractor covers AB. And then the thick line of the protractor is on 90, or the baseline covers AB. We're now trying to measure angle 55 degrees. 90 minus 40 is 50. and then the middle line will now give us 55 degrees. That is it. So having done that, we'll now join the incident ray. We'll join this. We'll have that to get angle 55 degrees. Having done that, we put our optical pins and do the experiment at once. We have the first one on that straight line. Then maintain a distance of 4 cm and draw the scone, put the scone pin here also. Yeah, that is it. Make sure they're in a straight line. You bring back the rectangular block so they can view the images from the side DC with the search pin. We now look for the images on a straight line. We go down and view. So we have give them on a straight line. One is here. Okay, you see the images. One blocking the other. You put the pin, and then you put the scone pin to block the first search pin. So that is it. So when you have done that, you remove the prism, remove the pins. The first pin here is a P1, P2, P3, P4. Join with a straight line. Let the straight line pass through P3 and P4 and hit the prism at the point I. We now join I to O to create the refracted ray. So, see, going in and then going out. So having done that, we choose the coordinate radius. The radius we use is 3 cm. We maintain the same radius all through. The same 3 cm from the meter rule. Then put your pin or protractor at O and draw a circle. You see that? So that is okay. A circle cutting through the refracted ray and the incident ray. When you have done that, you draw a perpendicular from the incident ray, from the circumference where the incident ray cut the circle, and then draw a straight line to hit the normal. Here is your E, F, also known as small d. Then also from the point where the refracted ray cut the circumference, draw a straight line to hit the normal. Here is your G. Here is your H, which you call L. So we're now going to measure EF for angle 55 degrees. So EF for angle 55 degrees, you get it right, is about 2.6 cm. So our EF or small d is 2.60 cm for angle 55 degrees. Then we measure our GH for angle 55 degrees. Our GH is around 0. It's very small. Our GH or L is around 0.50 cm. So, having done that, we'll now move to the next experiment. And then, for this one, this is angle of 65 degree, 65 degree. So this point already is our O. We already marked it out. That is 2.6 cm. One quarter of AB, 2.6 cm. So we'll draw our normal. Draw your normal or straight line. Okay. So having done, you do that. That is it. Having done that, we're gonna bring a protractor and mark out angle 65 degrees. The baseline covering AB and the thick line 90 covering the normal 65 degree. 90 minus 30 is 60. So the middle line after 30 is 65. That is there. And when you have done that, you then draw your straight line. You can see that. So that you can make angle of incidence of 65 degree with the normal. So you see that. So when we have done that, we'll put our pin back to get the object pins, and they must be on the line. Then the scum pin will be distance of 4 centimeters. Be careful to use the cm end in your measurement, not the millimeter end. The meter rule has cm millimeter, so you have to use cm end. So cm, 4 cm from the first pin, which will be maintaining throughout the experiment, is a precaution. The pins should not be very close to each other, so they should be at least 4 cm apart. You can use 5 cm depending on you. So you now bring the rectangular block and replace it, cover the outline very well, and then view the images. Go down and view it. Observe them in a straight line. So I can see one. I can see that one of them, one is covering the other one. That one they're in a straight line. So you put this pin, and then you put the second pin to cover the first search pin. So blocking everything. So having done that, remove your pins. Here is your P3. Here is your P4. So here is your P1. Here is your P2. Then you have to draw a straight line to join P3 and P4 and produce the line to hit the face of the prism, which is a DC at the point I. Having done that, then draw a line to move from I to O, a straight line, to join the point I here to the point O. So you have that. So be sure what you're drawing, make sure it's straight. No mistake. You see, it's perfect. So this is the incident ray, the arrow entering, reflected ray leaving, and then the emergent ray also leaving. Then with your protractor, you measure a distance of 3 cm. Radius, keep the same radius constant. So this is 3 cm we are using here. And then draw with your center at the pin at O, or the protractor of the compass at O. So then you draw your circle to cut across the incident ray and the refracted ray. So when you have done that, you now take your pencil and draw a perpendicular or a straight line from the circumference, that's the point where the incident ray called the circle, to the normal. And also draw another one from the point where the reflected ray called the circumference to the normal. So you see that. So this place is your EF, known as your small d. This place is your GH, known as your small l. So you measure EF for angle 65 degrees. You measure EF with the cm end of the rule. EF is given us approximately 3.3 cm. 3.3 cm. So EF, which is D, is 3.300 cm. And then we now measure GH. GH is our L. And GH, let's measure it. GH is giving us a small value of approximately 0.300 centimeter. So we now take our readings. For angle of incidence of 25 degree, we have it 25.00. The D, which is our EF, is 1.30. We'll write here 1.300. Maintain your readings to 4 significant figures for consistency. Your GH, which is L, is 1.00. We'll write 1.00 to 4 SF. That is 1, 2, 3, 4. 1, 2, 3, 4. Everything maintained to 4 SF. Now, for angle of incidence of 35 degrees, our EF is measured, that is D, as 2.0. When I write here 2.0, triple 0 to 4 SF. And our GH or L is 1.2. We write 1.200 to 4 SF. So when the angle of incidence is 45 degree, we obtain our EF or small d as 2.50. When I write here 2.500 to 4 SF. Then our GH or L is 1.6. We obtain 1.6. We have 1.600. For an incident angle of 55 degree, we obtain our D or EF as 2.60. So right here 2.600 under, in line with 55 degree incident angle. And then our L or GH is 0.50. We have 0.500 here. So 000 to make it to 4 SF. Then for the last angle, 65 degree incident, our EF or D is 3.30. So here we have 3.300. And then our GH or L is 0.300. So here we'll write 0.300. So you can see our readings for the experiment. So you see that as the angle of incidence increases, the value of D also increases gradually. Likewise, the value of L, which is GH, also increases to a point. So the value of D increases from 25 to 65, 1.3, 2.0, 2.5, 2.6, and 3.3. Then the value of L increased from 25 degree to 45, 1.0, 1.2, and then 1.6. Then after 45 degree, there was a sharp decrease from 55 to 65. We have 0.5 and then 0.3. So after plotting the graph, we're going to see the shape of the graph and then find our slope. So you see that this experiment did not take us up to 35 minutes. So 35 minutes for experiments, which some students dread to do. So 35 minutes, if you're a student, it will even take you 20 minutes, because why it took me to 35 minutes, because I was teaching, explaining as I was doing it. But if I should keep quiet and do it with a total focus, it may take me less than 20 minutes. Likewise, you as a student, if you practice it, get your own block and practice this. So let's go to the graph. So here we have our process result. We have the angle of incidence 25, 35, 45, 55, 60. We have our D, which is equivalent to EF 1.3, 2.0, 2.5, 2.6, 3.3. Have our L equivalent to GH, or in cm 1.0, 1.2, 1.6, 0.5, 0.3. Everything recorded to 4 significant figures. So we're asked to plot D against L. D against L. Look at the values of D, the range from 1.3 to 3.3. So to plot D, let's go to the graph. On the vertical axis, we can choose a scale of 0.5 to a bus, standard bus, or that's a bus is 2 cm, so 0.5 to 2 cm. So after 0.5, we have 1.0, we have 1.5, we have here 2.0, 2.5, 3.0, 3.5. So we can stop at 3.5 because the highest value on the D axis is 3.3. So for the horizontal axis, that is our L, we can choose a scale of 2 buses for 0.5. That is 4 cm to 0.5 unit. So after every 2 bus, you have 0.5, 0.5. The next 2 bus will now be 1.0. The next 2 buses will now be 1.5. The next 2 buses will now be 2.0. So let's cross check our work. If we look at the readings for L, we have This value is 0.3. The higher value is 1.6. So that covers everything. So writing our scale up, we can say on the axis, we have the scale 2 cm to 0.5 unit. Then on L axis, which is the vertical horizontal axis, we have 4C, and that is 2 buses, to 0.5 unit. So let's now understand the scale. So there are 10 lines in the bus. That means each line is going to be for the D axis, each line is going to be 0.5 over 10. So each line gives us 0.05 units. So for the L axis, there are 2 buses here, and 2 buses gives you 20 lines. So for the L axis, one line will now become 0.5 divided by 20. So what we'll do that, 0.5 divided by 20, we're going to have to calculate it, 0.5 divided by 20. You get it? Will give us 0.025. So for the horizontal axis, one line is 0.05 based on the scale we're choosing. And for the L axis, which is the vertical axis, one line is 0.05, sorry. And the horizontal axis, L axis, one line is 0.025. So let's start plotting our graph. We'll go to the table of value. Let's find 1.3 on the D axis. So 1.3, since one line here is 0.05, that means 2 lines will be 0.1. So this is 1. The next 2 lines is 1.1. The next 2 lines is 1.2. The next 2 lines is going to be 1.3. Then we now move to the horizontal axis. So for this one, L, 1.3, then L is 1. So now move, this is 1. We move up and merge it with 1.3, which should be here. So 1 goes with 1.3. Then move to the table of value again, 2 for the vertical axis and 1.2 for the horizontal axis. So you can see 2 here on the vertical axis. The horizontal is 1.2. You see, in this one line is 0.025. So we count it. If one line is 0.025, that means 4 lines will give us, we'll multiply 28, 10, 28, and then 4 times 5 is 20, carry 2, 4 times 2, 8, plus 2, 10, carry 1, 4 times 1, 0. For 4 lines will give us 0.4. That means 8 lines will give us 0.2. So we'll now move here. So we'll count 8 lines. 1, 2, 3, 4, 5, 6, 7, and then 8. That will be 0.2. That is 1.2 here on the 8th line. We'll now move up, and then we'll get the value. Here is this 1 point. This is 2, and here is 1.2 on the horizontal, and here is 2. So this is where the 2 values merge. Then, having done that, we now go to the third value. 2.5 goes with 1.6. 2.5 with 1.6. 2.5 on the vertical, 1.6 on the horizontal. So 2.5 is already on the graph. We now locate 1.6. 1.6. Since on this axis, one line is 0.025. So here is 1.5. The next 2 lines will give you 1.55. Next 2 lines will give you 1.6. So that is this. 1, 2, 3, 4. We'll now move up to 2.5. 1, 2, then 3, 4. It should be here. So having done that, you see that we'll now move to 2.6. The values are getting smaller now. Our 2.6. So we'll see that as the angle of incidence increases, the emergent ray, what we did in the experiment, was coming close to the normal, and then the angle of emergence decreases. That's why the values here are getting smaller. So 2.6 is merges with 0.5. So we locate 2.6 on the vertical axis. 2.6 is here is 2.5. One line here is 0.05. So 2.5, 2.55. The second line will now be 2.6. So it merges with 0.5. And 0.5 should be here. So that is it. Then we also have 3.3 merging with 0.3. So to get 3.3, we read one line is 0.05. This is 3, 3.05, 3.1, 3.15. Repeat again. 3.05, 3.1, 3.15, 3.2, 3.25, 3.3. So it goes with 0.3 on this axis. So 0.3, we have 4 lines, 8 lines is 0.2. So that means 12 lines will be 0.3. So we count it. Here is 1, 2, 3, 4, 5, 6, 7, 8. That is this 9, 10. This is 10 lines, then 11, 12 lines. Since one line is 0.025, so 12 lines will give us 0.3. So we take it up, and then we have it here, 0.312. That is here, accurate. So when we are done that, we see our graph having a kind of inverse shape. You can see the shape of the graph going like this. So if I put the line like our ruler like this, 2 points will enter. You see that? We put a ruler like this, we're having a kind of almost 3 points entering. That means the graph is an inverse graph. So we'll draw our graph, our straight line. You see the graph there, an inverse shape graph for this particular experiment. So we're about to take the slope of the graph. So we'll have to take 2 points on the straight line. The last point, the coordinate here is 0.3. And then down there, the coordinate on the y-axis is 1.2. Then going to the horizontal axis, the coordinate for this one is 2. There is for this one is 1. Sorry, not 2. Here is 1. While this place is, let me get it clear. Coordinate here is 1. While the coordinate here is around 0.3. So 1 and then 0.3 here. While this place is giving us 0.3 and 1.2, 0.3, 1.2. Why we have here 1 here on this side, L, and then 0.3. So here is not 0.3 error. Here is 3.3, sorry, 3.3. That's the value here. And then the value on this this point, the lower coordinate of y-axis is here is let's read it very well. Here is around, so let's correct that abnormally. The coordinate on the y-axis is here. Axis is 3.3, the upper coordinate that is close to 3.5. Then the lower coordinate is 1.3, below 1.5. So going to the horizontal axis, the coordinate here is 1.0. And then here we're having the coordinate of 0.3. So 3.3 and 1.3 for the vertical, 1.0 and 0.3 on the horizontal. So finding our slope now becomes change on D axis. The D is EF axis. All about the change on L axis and LEGF axis. We're going to be 3.3 minus 1.3 all over 1 minus 0.3. So when we solve this out, 3.3 minus this gives us 2. All over 1 minus 0.3 gives us 0.7. So 2 over 0.7 gives us approximately 2.9. So what could this slope probably represent? This slope should represent the radius of our circle. Remember that during the experiment we chose a coordinate radius of 3 cm to draw the circle that cut across the incident ray and the reflected ray. So we chose 3 cm and we're getting a slope of close to 2.9, which is approximately 3 cm, which proves our experiment correct. Radius of the circle that we use for the experiment. So if you choose radius of 4 cm, so you expect to get a slope of 4 cm. You use radius of 2 cm, you get a slope of 2 cm. So let's go to the remaining questions for this experiment. So the next is precaution for the experiment. I ensure that I avoided error due to paragraphs in locating the images using the search pins. That's one precaution. I ensure that I avoided error due to paragraphs in reading. This will be reading the protractor and the meter rule. So these are two major precautions. You can still say that I ensure that the laboratory was well illuminated because I cannot perform the experiment in a dark place. Then the other question says we should state Snell's law. Snell's law states that the ratio or sine of angle of incidence to the sine of angle of refraction is a constant for any given pair of media. The other question says that we should calculate the critical angle of water when we're given the index, referring index as 4/3. So the critical angle is given by sine inverse of 1/n, where n is referring index. So we now have a sine inverse of 1 over, put 4/3 here. You have 1/n, you now have 1 all over 4/3. If you invert, you're getting 3/4, which is nothing but 0.75. So that's how we got the 0.75 here. Sine inverse of 0.75, and that will give us 48.6 degrees at the critical angle. So remain connected to this channel as we bring to you model 3 of the physics experiment.